This research is aimed primarily at teachers. It endeavours to illustrate the importance of skip counting from the earliest years and why it is an important concept for children to master. For young children, understanding skip counting is closely related to their experience of counting singularly 1, 2, 3, and so on. Most children in their preschool year will have understood this concept and therefore begin the foundation year with a grasp of singular numbers. What a child brings from home is furthermore invaluable as it reinforces their knowledge of numbers. Sorting and identifying objects into sets and categorization is an experience of forming equivalences. Students in the early years of formal education may use toys and blocks to categorize. This relates not only to their understanding of number value but also in their language development. When a child can distinguish between small numbers and understand that they are used to describe sets of objects, this becomes invaluable preparation for skip counting. Skip counting is a mathematics technique that most children learn from the foundation grade. Skip counting is counting numbers other than 1. In the early years, it is common and an easy concept to understand if a child starts counting by twos. From there, as teachers, we can get children to count in fives, tens, 20s, and so on. Going beyond that level of skip counting can then help a child see patterns, and eventually this will introduce and reinforce the concept of multiplication. Skip counting also helps when teaching a child how to read a clock as you count in fives, and 2 as you read a thermometer. It also extends a child's knowledge of number and assists in their learning of adding and subtracting. Skip counting develops skills that lead to understanding many mathematical concepts. As a teacher, skip counting is an important concept to impart, especially in the early years, as it introduces children to number patterns. This also helps with division and subtraction, like 10 toes and 10 fingers, 10 plus 10. It is essential for children to understand place value and number patterns in the number system, so they can move on to addition and subtraction. It also is a strategy that can be used to support multiplication and division in later mathematical development. Repeated addition is the basic skill. 3 and 3 and 3 is 9. When multiplying, you might have 5 groups of 7 is... So if you count by fives, it will make it easier to work out. If you have a sharing question like 30 shared between 5 is... Then the same applies if you can skip count by fives. Skip counting by tens from 0 is the easiest, then fives, then twos. Then skip counting by tens, fives, and other numbers from a non-zero starting point is the next level, and recognizing the pattern, such as 24, 29, 34, 39. Rees et al. 2012 points out that skip counting occurs in everyday life. It provides a child with early recognition of odd and even numbers and readiness for multiplication and division. Rees also points out that skip counting is an integral part of many activities in which children are involved. Many sports provide opportunities for skip counting, such as 2s and 3s in basketballs and 6 in football, representing a goal. Rees also importantly points out that skip counting, coupled with counting forward or counting back, provides excellent preparation in counting change in monetary transaction in later years. These examples illustrate the important concepts underpinning skip counting and lead to future work in multiplication and division. Research by Hewitt and Brown, 1998, states we have found the explicit instruction focusing on bridging tens, hundreds, and thousands, forwards and backwards, is productive. I believe that the conceptual basis of all skip counting supports this. It is important for the teacher to maintain a cognitively yet play-based classroom, which is reflected in Jean Piaget's theory. This is based on stages that children go through in order to learn. In each stage, the learning process is different and a little more complex. Piaget believed that children should play, experiment, and reason in order to learn. Lev Vygotsky believed play also creates the zone of proximal development of the child. In play, the child is always behaving beyond his age, above his usual everyday behaviour. In play he is, as it were, a head above himself. Doyle et al. 2006 supports this concept, revealing children learn best through hands-on discovery, learning while working with tangible objects. This supports evidence that play-based learning is appropriate for early childhood students, and we as teachers are to make these play-based experiences accessible within our classroom. Flea in 1998 also states, what children pay attention to is determined by what is in the environment that can be explored. Having items around the room that students can see in pairs is very important. Having items within reach and that children can relate to can evolve their thinking. Saying sequences by 2s, 3s and 5s on and off the multiple supports developmental of multiplicative knowledge. The pedagogical approach of adaptive platforms, I believe, would necessarily involve a teacher explaining, you can also count by 2s, 5s or 10s. In this content delivery model, the student is receiving someone else's idea and strategy. A fantastic platform and pedagogy could perhaps be offering a specific game that empowers students to develop ideas and skills of their own. A great example of this would be to gather children in a circle as a whole class group and sit around 10 lily pads that are labelled with numbers 1 to 10. The teacher may ask a very well-behaved student to attempt jumping like a frog in 2s, leaping all the way to 10. Students around the circle can whisper in 2s, 2, 4, 6, 8, 10. This is not only a fun-based approach, but other students may start to develop their own ideas, but they start to realise and understand there is a pattern taking place. They may start to realise there is a space in between 0 and 2 and take notice of the odd numbers. Another example of a suggested method to teach skip counting would be for the child to understand the written word, so 2, as well as a visual representation such as 2 dots. To make the child understand that, this means the same things would be ideal. A student could then extend that by counting in 5s and 10s. Once a student can demonstrate number sense and apply the number theory, students will be able to explore, recognise, represent and apply patterns and relationships, both formally and informally. Teachers should cater for all types of learning, visually, kinesthetically, etc. A good way to do this is to begin a lesson by asking the class to come up with items around the room that are in pairs. What else could be in pairs? These are questions we can ask them. Or groups of 2, and people can look at their hands, feet and eyes. From there, the teacher extends these activities using the hundreds chart, and the group can look for patterns using a highlighter, a number line, circling numbers and drawing on the leaps between them. It's also really fun to play skip counting CDs such as Jack Hartman. You can find them on YouTube to encourage the kids to learn through repetition and rhyme, and these are really popular with the early childhood such as prep. When you teach skip counting, it's really important to record it vertically so children can see the patterns in the 10s and 1 columns. So on the board, on a piece of paper, you would write 5, 10, 15, 20, 25, 30. You could keep going depending on the child and depending on the year level, but they can actually see the 1, the 2, the 3, the 4. You can see it change. At the start, kids will use their fingers to help, but soon they should see a pattern. Silent counting also helps when they whisper 1, 2, 3, 4, and say 5. Whisper 6, 7, 8, 9, 10. In conclusion, this video should not only explain what skip counting is, but more importantly, why it forms an integral part of a child's mathematical learning and how it can be introduced in a fun, play-based way, relevant to young children. Failure to successfully teach children about number sequences and patterns will ultimately be detrimental to their development in the more advanced concepts of multiplication and division.